So as we begin a new round of videos, I want to start this one with multiplying fractions. So let's look at the example 3/4 times 2/3. And one of the easiest ways to see this is using what we call the area model. Remember, to find area of a rectangle, you multiply the side times the side. Now this is going to be a square. Each side of the square is going to be 1. So to make 3/4, I'm going to cut this side into 4 equal pieces. And so I'm going to come across here and make my little cuts across there. So that should be 4 equal pieces that way. And then notice how this is 2/3. I'm going to cut this into 3 pieces the other way. Those are supposed to be equal pieces. So 3/4 means you have 1/4, 1/4, and 1/4. So 3/4 means you got to take 3 of these things. I'm going to use a different color here when I do that to make it a little bit lighter. So 3/4, I'm going to take this here, and this here. And then the 2/3 means we're going to take 1/3 and 1 more third. So I want to now shade in that, but I only want to shade where I've already shaded. So I only want to follow the yellow there. And so where you see yellow and blue is going to be the area that we're talking about. So the area that we talk about is only going to be this part right here. So we got to figure out, well, what fraction of the square have we actually taken? So if we count, we've taken 1, 2, 3, 4, 5. We've taken 6 pieces. But the question is how many pieces were there to begin with? So if we look at the whole inside of the square, there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So what we see is we have 6 out of 12 pieces are shaded. That's how much area we actually covered. And 6/12, notice we can divide the top and bottom both by 6, and that would give me like 1/2 or 1/2. So what you can see from this example, though, is it actually becomes very easy to multiply fractions. Instead of drawing this area model, which takes a lot of time, what we pick up on is all you're really doing is multiplying 3 times 2, which gives me 6, and 4 times 3, which gives me 12. So to multiply fractions, what you can do is just multiply straight across and then reduce. So if you multiply straight across and then reduce, you get your answer of 1/2. Now there's another way to do the problem, which is what we call canceling. So if I have 3/4 times 2/3, another way to do the problem is what we call canceling. Canceling also means this reducing thing. So what we can look at is if I look diagonally, if you notice there's a common divisor here, both a 4 and a 2 can be divided by a 2. So what I can do is go 2 goes into 2 one time, and 2 goes into 4 twice. So canceling kind of means to mark out or divide out. If I look to my left diagonal here, notice that the 3 and the 3 have a common divisor of 3 in them. So I can divide a 3 out of each one of those. So 3 goes into 3 one time, and 3 goes into 3 one time. And the catch is just making where it's legible. And once you've done your canceling, then multiply straight across. 1 times 1 is 1, and 2 times 1 is 2, and you get your answer of 1/2. So there's 2 ways that you can multiply fractions. You can multiply straight across, then reduce, or what we call canceling, and then go straight across. So like I said, if I'm doing this problem 3/4 times 2/3, multiplying straight across, you get the 6 and the 12. And then to reduce means you have to be finding that greatest common factor. So that's when you, if you need to, is you can do your little T-charts of the 6 and the 12. So I have a 1 and a 6, a 2 times 3, 3 times 2, That just repeats. So I have 4 different factors for 6. 12 has a 1 and a 12, a 2 and a 6, a 3 and a 4, 4 and a 3, that's just repeating. So that's 6 different factors. But if we notice, though, the 6 is the greatest common factor. So if I divide by 6 on the top and bottom, that is going to give me this 1/2. So that's kind of doing that problem a little bit slower. And again, 3/4 times 2/3 canceling means you're looking diagonally at the top and the bottom, the numerators and the denominators diagonally. If there's a common divisor, we want to take that out. And I see that these both have a 2 in them. So 2 goes into 2 one time, and 2 goes into 4 twice. So I divide the 2 out there. Then if I look diagonal this way, these 3's both have a 3 in common. 3 goes in 3 one time, and 3 goes in 3 one time. And that's what we mean by canceling. And then we multiply straight across. 1 times 1 is 1, and 2 times 1 is 2. And there's that 1/2 again. So there's 2 methods of doing that. Now sometimes they'll give us mixed numbers to multiply. The easiest way to do this problem is change these to improper fractions. So if I go 2 times 2, which is 4, plus the 1, that gives me 5/2. I can change that to an improper fraction. And then we're multiplying, not adding. So we're multiplying. 4 times 1 is 4, plus 3 more makes 7. So it's going to be 7/4. And so what I can do is I look for canceling. I don't see any canceling. So if I multiply straight across, we get 5 times 7 is 35. And 4 times 2 is 8. So that would be an improper fraction, which I could change to a mixed number. So 8 goes into 35. And again, if you know your math tricks, your 8s, you can kind of do that 0, 1, 2, 3, 4, 4, 5, 6, 7, 8. Oops, ran out of room there. Then I had 0, 1, 2. I have to do that all over again. I did give myself enough room. Yeah, so we'll do that again. So if I try that again, get myself up a little higher. 0, 1, 2, 3, 4, 4, 5, 6, 7, 8. Still can't make myself fit there. I'm just writing too big. Get the idea, don't you? Who knew that running out of paper would be a big issue? And then 0, 2, 4, 6, 8, and 0, 2, 4, 6, 8. So how many 8s could get me close to 35? That would be that 32. That would be 4 8s is 32. Then my remainder is going to be 3. So it'd be 4 and 3/8. So I could change that into a mixed number by using long division. So the 4 is my whole number, and remember that the remainder is part of your fraction 3/8. And this should go back to 35/8 if you put it back together. So they should be equivalent. They're just in different forms. So division of fractions is where things start to get a little more tricky. Because again, division we're not strong with to begin with. But remember, we said in division problems, we can go inversely. If we go in the other direction, I could see this also as multiplication. So I could say 8 times 2/3 is equal to, so some number x times 2/3 is going to equal then this 3/4. So I can change it into a multiplication problem. And also this is an equation, so I can also use equation thinking. And remember, multiplication order does not matter, so I could change this 2/3 into a coefficient. So 2/3 x equals 3/4. And so basically what we're trying to figure out is, 2/3 times what number is going to be 3/4. And remember, to solve for x, you got to make the coefficient equal to 1. And I can do this in 2 steps. I can make the 3 go away by multiplying each side by 3 because the 3 is related by division. So to make division go away, I can use multiplication. So I can multiply each side by 3. So the 3's will divide out, and I have then this 2x equals then 9/4. And then to make the 2 go away, you can divide by 2. So I can just make my fraction bar a little bit further and put the 2 underneath. So it really means there's a 4 and a 2 that we're dividing by. So that's just going to turn into then this 9/8. So remember, if there's a 2 on top, we got to put a 2 on the bottom. And that's where we get this 9/8 at. So what we pick up on is there's a strangeness to this problem. And we're going to talk more about that in our next video. So to make division work a little bit easier, what we're going to talk about is something that's kind of cool. If you multiply a fraction by its reciprocal, in other words, if you flip the number, the product is going to equal 1. So in other words, if I give you 5/8, if I multiply by its reciprocal, in other words, if I flip it, that's going to give me this 8/5. What happens is that's going to equal 1 because remember the canceling, these are going to cancel out, become 1s, and these are going to cancel out to become 1s. And so what you have is 1/1, which is really the same thing as 1 whole. So what we pick up on is I can make a fraction turn into 1 if I multiply by its reciprocal. So if I'm given 3/4, if I multiply by the reciprocal, in other words, flip it to 4/3, that is going to equal then 1 whole. Because notice again how the 3's are divide out, the 4's divide out, so all that's left then is 1. So if I have 1/2, if I multiply it by its reciprocal, which would be 2/1, again, that's going to equal 1. So what we learned is, if I want to solve an equation, our goal is when the coefficient is a fraction, we want to multiply each side by the reciprocal to make the coefficient equal to 1. So see how the coefficient right now is a 1/3. To make it equal to 1, I can multiply by its reciprocal, which would be then a 3/1. If you multiply by 3/1 here, you got to multiply their side by 3/1 to keep the property of equality working for us. So this all turns into a 1, which gives me my x. And then we can multiply fractions. 3 times 3 would be 9. 4 times 1 would be 4. So you would have then 9/4. And you can leave it as 9/4 since I don't see any mixed numbers involved here. Improper fractions are okay. So if I want to solve this equation for m, what we can do is we can multiply by its reciprocal, which is going to be 5/3. So if I multiply this side by 5/3, I got to multiply the other side by 5/3. So the 5's divide out, the 3's divide out. That leaves me my m. And when you multiply fractions, you can cancel first. So I see that a 5 goes out of that. 5 goes in 5 one time. 5 goes in 10 twice. If I go across, 2 times 1 is 2. 2 times 3 is 6. There's still reducing to be had. I must have missed something. Well, 2/6 does reduce down to 1/3. So there was a common divisor. So fractions will always be put in lowest terms. So 1/3 would be the final answer. So if I want to solve for p, notice how the coefficient is a fraction, 3/4. To make that fraction go away, I can multiply by its reciprocal, which is going to be 4/3. But if I multiply by 4/3 over here, you got to multiply by 4/3 over here. So the 4's divide out, the 3's divide out. So p is going to equal then, and you can write that 2/1 if you want to make it look like a fraction. 2 times 4 is going to be 8. 1 times 3 is 3, so 8/3 would be the answer. So we can solve equations with fractional coefficients, which will take us to our next level of thinking. So back to a division problem, 7/8 divided by 1/16. It's got to equal something. Remember, the something is usually called the quotient. So if I want to find the quotient, inversely, what I can do is go the other direction, and I can say x times 1/16, or in other words, I can say 1/16 times x to make it a coefficient. It's going to equal then this 7/8. And again, to solve for x, what we learn is all we have to do is multiply by the reciprocal. So if I multiply this side by 16 over 1, I got to multiply this side by 16 over 1. And therefore, x is going to equal then 8 will go into 16 twice. 8 goes to 8 one time. So 7 times 2 is 14. 1 times 1 is 1. And 14 over 1 is really the same thing as 14. That's just a whole number. So my answer turns into that, 14. So what this leads us to then is there's a shortcut for division. We call it the KCF method. In other words, we're going to use some simple language. Instead of using reciprocals, we're going to use this phrase keep, change, flip. So KCF stands for keep, the C stands for change, and the F stands for flip. So if I'm dividing fractions, all we got to do is keep the first number. So if I have 7/8 divided by 1/16, I keep the 7/8. I change division to multiplication, and then I just flip, use that reciprocal, 16 over 1. And notice how that kind of mirrors their side of the equation that we had. So again, now I'm just in a multiplication problem. We can cancel if we're good at division. And then 7 times 2 would be 14. 1 times 1 is 1. So we end up with 14 as an answer. So if I'm dividing fractions, instead of writing it as an equation, we just use KCF to make it easier. So that's how we have fractions involved. So it's a good idea to make that a 12 over 1. So to divide these fractions, we keep the 12 over 1. We change division to multiplication as long as we flip the 2/3 to 3/2. And then if I do some canceling, we see that the 2 goes into 2 one time, and 2 goes into 12 6 times. And then we have 6 times 3, which is 18. 1 times 1 is 1. Therefore, the answer is 18. So that's how we could divide those two fractions without a calculator. So 6 divided by 3 and 1/3. Again, let's make this look like fractions to start with. So 6 would have to be 6 over 1. And to make a mixed number look like a fraction, we can use our little strategy. 3 times 3 is 9 plus 1 is 10. So I could change that to 10/3. So now it looks like fraction math. So now we can use the KCF, 6 over 1. Keep, change division multiplication as long as we flip to 3/10. And I do see some canceling. The 6 and the 2 both have a common factor of 2 in them. So 2 goes into 10 5 times, and 2 goes into 6 3 times. And then we can multiply straight across. 3 times 3 is 9. 1 times 5 is 5. And 6, and since mixed numbers were present, I may have to change that to a mixed number. So 5 goes into 9. 5 goes into 9 one time. 1 5 is 5. If we subtract the 5, we get our remainder of 4. So we see that that answer would be the same thing as 1 whole and 4/5 of another. Instead of saying 9/5, we could say 1 and 4/5.